Don't normally look at it in that perspective, so I'm quite chuffed with that.
But when production ramps up in the new building, Sean will need to build nearly double the amount of pistons.
Basically, this is the what we call the 600 oven. It's the main heat treat quench oven. When I can get it through the gate. It's a bit of a tight squeeze and they're quite heavy.
To optimise the piston's basic metallic structure, the forgings are cooked again at 485 degrees C for 10 hours. The parts are then dropped into a secret solution. This type of alloy increases in strength as it cools. Then they're cleaned through an acid line, removing the graphite lubricant that was used in the forging process.
It can burn you, so it's best to wear your apron, long gloves and the visor.
They're placed in acid for 4 minutes and then washed off before they go into another of Sean's special solutions.
In here we have tiger juice. Put it this way, if I was to put some on the concrete, we'd see bubbling and it would disappear down towards the centre of the earth. It is like wash it up, but don't tell the wife, otherwise she'll have me doing it at home as well. As you can see, before acid, after acid. Now we come to the fun bit. Pushing this into the aging oven, something you have to put your back into. Close the door. Check the temperature. 185. Job done.
At full speed, each piston travels up and down 140 times a second. So precision engineering is essential. The piston goes through a process of further aging, milling and machining before being put together.
So this is where we actually put the piston together with the piston rings, gudgeon pin and all the pins that go with it. And this is ready just to be packed up in the packaging and actually sent to the engine builder. So we have a full set of engine pistons and a set of engine liners. The engine liner will go in the block, the piston will get connected and then assembled together. And then that basically is what you've got, the heart of a supercar. Then you turn the key, 170 mile an hour and away you go.
Just up the road at a specialist engine manufacturer, the rest of the parts are assembled, with the pistons taking their place in the engine head. But this company doesn't just build the engine, they also create what it will actually sound like.
My name's Matt Maunder. My job is basically to make cars go vroom vroom as nicely as possible. That's my job.
You might think the sound of the engine is just a byproduct of the moving mechanical parts, but it's actually been designed by an engineer.
If you've paid extra money for a sports car, you really want to have something that's going to make the hairs on the back of your neck stand up, a bit more vroom vroom.
And when it comes to how a car should sound, this man is obsessed.
This is the Ricardo car park. We're going to have a look around, see what cars we can see. That's a Japanese car, that's probably pretty quiet, I should think, that one. BMW, that'll be tuned up for the American market a little bit more rumbly. That's a Lotus Esprit, isn't it? I think that's a turbo engine. And yeah, they're pretty much a high-speed European-style screamer, that one. And they're all four-cylinder cars, and they're all a bit dull. British people definitely like a bit more exhaust sound coming out of their car. I guess it's kind of a throwback to sort of motor racing history that we've got in this country. Yeah, Americans tend to like more of a burbly V8 sound. Italian cars tend to be a bit kind of shiny, pointy shoed, you know, and a bit girly sometimes, but they kind of squeal beautifully, I think that's what Italian cars do. Japanese don't seem to care about the sound of their cars, so they're quite happy to have something that's just quiet and innocuous. I mean, there's a Honda there, but maybe they're too polite to have a raunchy car sound. That's what it is. We did a study that showed that sound made up basically half of the feeling of sportiness. So part of it is the feeling of acceleration being pushed back into the chair, but the other part is the oral onslaught you get coming to your ears from the engine.
McLaren's brief was concise.
They wanted it to sound really extreme as a sports car, in fact. So first part of the work we did actually was to try and find out what that meant. So we've got here the sort of the most boring sounds. So McLaren thought this one was dull, normal and weak, no character, like a Kylie Minogue pop tune, And then this one is the kind of Kanye West, very well produced, smooth, precise, pleasant. I quite like that one. Whereas this one is a bit more extreme, a bit more rough around the edges, a bit of a dizzy rascal, that one. Welcome to the least echoey room in the world. Basically, these wedges are made out of absorbent foam, and they actually absorb the sound. But because of the shape of the wedges, as the sound comes in, it bounces further into the cracks. So it also hits the foam multiple times and never comes out again. That's the idea. Which is the same effect as you would get if you're outside on an open field, where the sound just travels away and there's nothing to reflect it back again towards you. And that's why it sounds a bit strange. So this is our workhorse car, which we've been using for the development of the sound of the car. The business end is at the back, of course.
The 12C has a relatively small 3.8 litre engine. To get the power associated with a supercar, engineers have bolted on twin turbochargers, which force more air into the cylinders, creating an even higher combustion level.
The turbocharger actually cuts down a lot of the sound that comes out of the exhaust pipes, which isn't really good for a sports car. We want to have as much noise as we can coming out of there and tune to a nice sound as well. So one of the key things we've had to do on this car is to tune the exhaust system to match up with the turbochargers so that we can get the right kind of sound out of the back of the car. The engine is like the breathing, spitting heart of the car, and then it's got two saxophones on the back of it. And by tuning the exhaust system to get the right kind of mixing between the different cylinders, that gives us the Metallica sound that we were looking for earlier on. So that kind of got a bit of oomph to it, hasn't it, that? I really like that. I can really say, like, I did that. I made that car sound like this, and that just makes me feel quite proud.
How do you feel the sound is?
I like it.
Yeah?
It's sports mode.
Really? I can't hear it.
You put it in track, it's good. Oh, he's going. See ya.
Give it some so I can hear what it sounds like from here. Right, just here. Okay, we're on the runway. Slippery as hell. 4,000 RPM now. Now I'm dumped.
Professional racing drivers might have pushed the new car to its limit, but most customers won't be driving it on a racetrack. It's a road car, so how it handles on different surfaces all around the world is a top priority.
We use these secret proving grounds for two reasons. One is confidentiality, so that we can develop our product to a level where we're happy to sell it. So, if we're going to make any mistakes, we want to make them in relative secrecy. The second reason that we come to proving grounds is that you can pretty much do within reason what you want with the car in terms of speeds and how fast you go around corners, and obviously you can't do that on the public road.
This kind of testing allows them to find and fix faults before customers do, and they use specially built roads to do it.
So this surface is a specifically designed, badly maintained road. It will expose any squeaks and rattles. We're now going on to the Belgian pavé surfaces. So these generally give shorter wavelength inputs into the car and expose any kind of secondary ride issues that it might have, or if anything is going to drop off the car, it would be here. It does rattle you around a little bit driving over these things. These are the washboard surfaces, which are quite harsh. and not dissimilar to sort of cat's eyes on a motorway, but more severe. It's quite difficult with a sports car that needs to be stiff in the corners to also be compliant on the bumps.
The new car has some very clever engineering which should allow it to cope with most road conditions. At each corner of it, there are independent spring and hydraulic dampers. Fluid-filled chambers are linked to each other. As high pressure meets high pressure under roll, the chassis stiffens. But to have a more comfortable ride on a badly maintained road, hydraulic lines connect the front and back, allowing each wheel to operate independently.
The car has got a number of discrete suspension settings which allow it to become moderately firm on rough surfaces, but at the flick of a switch you can turn it into something that's also very responsive on racetrack kind of environments. So Jack and Hyde, I think, is probably the best description you can give.
The team work with a fleet of over 50 prototypes, and one of the oldest is maintained by engineers like Richard Yeo.
It's a workhorse basically, so it's just kept running, patched up, and does its job. Temperatures coming out of the exhaust are approximately about 800 degrees, so we've seen problems with the bumpers melting before, so it's just a way of bypassing that and just carrying on.
When the team discover problems like the melting bumpers, tweaks and adjustments can be fed back to base to fix them.
This car does look proper Mad Max, but I can assure you all the equipment in the car is top notch and is the highest spec that you can get. As you can see, it's quite different to a production car that you would see on the line. We run quite a lot of data logging, 2 screens here so the driver can see everything that's going on with the engine, and also all these switches